Hello, hello. Good morning, good afternoon, good evening. We will wait a few minutes to let everyone connect. Maybe 1 minute more to wait for connection. Okay. So I think we can start. Hi everyone. Very happy to be with you today. So my name is Guillaume Dancoine and I will moderate the session of the day. So we are very happy to organize this trilogy of webinar. We have three sessions ongoing. The first one is today. The second one will be the 5th of September, and the 3rd of October we'll have the third one. So today the session will be dedicated to persistence of microbiological hazards in the food industry, highlight from EFSA Scientific opinion. And for that, we have two scientific guys with us. I will introduce them in a few seconds. Before that, just to let you know that all attendees are on mute mode, and to ask questions, please click on the question icon in the toolbar. The webinar is recorded, so we will send you the link after the event for your convenience. And of course, please take time, a few minutes, just to answer the satisfaction survey, which is very important for us. So the first speaker, in the order, in the end it will be the second one, but David Thomas Fons is Associate Director of Scientific Affairs at bioMérieux. He's the coordinator of the Committee on Reference Method for Food Microbiology at the Spanish Association for Standardization, and delegate at corresponding ISO and CN technical committees. He collaborates with the Research Institute of Food Engineering at the Polytechnic University of Valencia. He worked as a technical auditor in Spanish accreditation body, senior scientist at Nestlé Research, and as head of the Microbiology and Molecular Biology department at ENIA. He participates as invited speaker in international symposium and published several articles on food safety in peer-reviewed journals. He contributed as expert in food microbiology for international projects in collaboration with CN, EU, and FAO. And we have also Brice Minvielle. So Brice has been working for the food industry for over 25 years, mainly on the characterization of microbiological hazards and spoilage flora, and the effectiveness of control measures. He has been involved in several collaborative research projects on food quality and safety with the different stakeholders of the food chain, and also coordinated the elaboration of guides to good hygiene practice and HACCP principles and professional guidelines. He joined Kersia Group in 2020 as a global proficiency expert on food safety. Reporting to the Global Key Account Department, he provides global and local support on questions related to food quality and safety, and on the role of cleaning and disinfection to food hygiene. After a bachelor's degrees in biochemistry and molecular biology, he specialized in food quality with a MSc in agriculture. So please, Brice, I let you the floor for the first part of this webinar, and thanks again to attend this session. Brice, are you there? Brice, do you hear me? It seems we have an issue with the connection.
Okay, Guillaume, I was on mute for some technical reasons. Is it okay now?
Yeah, you can maybe open your camera and share your screen. I think you have the possibility to right now.
I did that, but apparently there was some issue. Okay, let's see. Can you see my screen now? Is it okay?
Not yet, but maybe we are sorry. It's always the same when we train ourselves, but live.
Yeah, we did a test. We did a test indeed.
Yeah.
It says that I'm sharing, so
maybe Stephanie, can you give me back the hand, because it seems that I'm still sharing my screen. So maybe I have to stop it. Okay, I stop it. So now, Brice, I think you can move forward.
Apparently,
okay.
Is it okay, Guillaume?
I will tell you that in a few seconds. Not yet. Sorry for no, we don't see your screen.
Do you see anything?
No, we see GoToWebinar. You know, the screen of GoToWebinar, but we don't see your your presentation.
Okay, but it says that I'm sharing the screen. So okay, let's see if I can. I don't have any message error.
If not, what we can do is just sending to me the presentation by email, and I will share it.
Yeah, I will try a last. It will be the last one, last attempt. Can you see anything now?
No, we are still. We only see me, your screen.
Okay.
We are sorry for that.
So okay, I will send you the.
David, I don't know if you can maybe.
Yeah, maybe David can start, and we will come back to
So David, you are there?
Yes. Yeah, I'm here.
Yeah. So maybe we'll start with you, David. Sorry for the.
No problem.
The issue. Okay?
No problem. Can you see my screen in full mode?
Yeah, perfect.
Yes.
So let's start by the microbiological part, and then we move to the more environmental part. So thanks for giving me the floor, and let's start. So I'm going to talk about microbiological hazards and focusing on what is described by the European Food Safety Agency as the most persistent microbiological hazards in food, and then I will summarize the conclusions. So what are the microbiological hazards? And again, I'm not the author of the document, so I try to summarize what is in the document and what can be benefit in 20 minutes to summarize a document of more than 100 pages. So apologize if it's not included. So I recommend you to go to the document if you have further questions or you want to have more information. So I think it's relevant to clarify what is described by the EFSA as a microbiological hazard. So here you can see what are the bacterial pathogens defined as an hazard, as a public health hazard. So Bacillus cereus, Campylobacter, Clostridium, Chronobacter, Listeria monocytogenes, E. coli, Cigatoxin E. coli, Staphylococcus, Salmonella, and Vibrio. So we have a list of bacteria that are described as are relevant for different sectors. So what you see, F is feed, animal feed, M is meat, fish, dairy, eggs, fruit and vegetables, and then the EFSA classified as low moisture foods, other composite products. So you can see these boxes are highlighting what is relevant for each food sector. So for example, Bacillus cereus in low moisture food, or Salmonella in all sectors, in animal feed, meat, fish, dairy, eggs, fruit and vegetables, and low moisture food. So, and for example, Vibrio only in fish products. So EFSA consider all those risks, but then they consider what is persistent hazard associated to environmental food. That's for me the key point of the report, that they are focusing on what is the impact of the environmental, the production environment, the facilities, the different areas, the different equipment that you use to involve risk in your food. And the document defines based on environmental persistent hazard should be detected at least twice in different time points, meaning that is resident, is something that you have in your facilities along the time, and is not associated to raw material. So it's something that is coming to your food because are living, let's say, in your environment and not coming in from the raw materials. So considering this definition, then the previous table is slightly changed. And then you can see that they have some colors. You have the orange and you have the red. So in this document from EFSA, the different pathogens are defined as orange if there is a risk of public health relevance, but is not associated with persistence, meaning that it's not isolated recurrently. So this is a general description, but of course, you can consider the Bacillus cereus in your facility and in your case could be a high risk. But in this case, according to the report, we should focus on Listeria monocytogenes in meat, fish, and dairy, and then fruit and vegetables. That's where Listeria monocytogenes has been defined as persistent in those sectors. Chronobacter sakazaki is identified as persistent in low moisture foods, you know, basically infant formula. And then Salmonella, although Salmonella is present in all sectors, is defined as persistent in animal feed, meat, eggs, and low moisture. So I think this is an important recommendation to highlight what is the sectors, what are the sectors impacted and what are different persistence according to the bacteria. So considering that, I'm going to talk a little bit about Listeria monocytogenes, Salmonella, and Chronobacter. The idea is not to describe sector by sector, but in the report you can find every sector, what is the risk, what has been associated, and that in 20 minutes I'm going to explain only what is relevant for Listeria monocytogenes in terms of persistence, and the same from Chronobacter and Salmonella, and not considering every specific sector. So moving to the next slide, you see that Listeria is already since 2005 described in the European regulation as a risk on manufacturer areas. So the European regulation on criteria, on microbiological criteria, is already mentioned that samples can be taken from processing areas and equipment used in food production and for food business operators manufacturing ready-to-eat foods. So meat, fish, or dairy ready-to-eat foods that might pose Listeria risk, they shall sample processing areas and equipment for Listeria mono. So 2005 already described that Listeria is an environmental risk, and now with this new approach from the report, we know that Salmonella and Chronobacter could be also environmental risk. So let's talk a little bit about each of these persistent risks. So let me start by Listeria monocytogenes, because you can see that is persistent in several food sectors. And just a general presentation from the European report on zoonosis from 2022, that you can see the number of cases of clinical cases of Listeria is not so high in Europe, almost 3,000, but the number of deaths is very high. So you can see that more than 10% of the people sick on Listeria monocytogenes die. So it's a high number in terms of danger and hazard related with Listeria. In case of the foodborne and the vehicles, when strong evidence has been found for outbreaks, you can see that meat products, in particular pig, fish, mixed foods, vegetables, and dairy. So we have split it also the risk of Listeria in the several areas that we presented before. So going to specifically why Listeria monocytogenes are persistent. So in the report and in general, if you are working with Listeria, you know what are the characteristics associated to Listeria monocytogenes. So it's a bacteria that is able to grow at low temperature, below 8 degrees, is able to grow and generate and reproduce, because they have cold shock proteins and unsaturated fatty acids. So some genetical and also phenotypical traits are allowing Listeria to grow at low temperature in your environment. Then also it's very known that the biofilm formation, so Listeria is able to form biofilms that you know is a resistance generating exopolysaccharides and then generating a matrix that is protecting Listeria from environment. Usually is more generating biofilms with association with other bacteria, but also alone, but usually with Pseudomonas or other bacteria are more stable biofilms. And again, we have some genetical traits that are associated to the capability of the biofilm formation. Resistant to osmotic shock, alkaline and oxidative stress is also important because this is making Listeria survive to some of the food process, and also resistance to heavy metals and some disinfectants, again associated to some genetic, we can define genetic capabilities to resist to some disinfectants, making more difficult the cleaning operations because the biofilm and the resistance to the disinfectants, and also making difficult to keep it under control because the Listeria can grow at low temperature. What else can we say about Listeria? So I think it's important, and this is a concept that is becoming more and more useful for food industry, around the subtyping. So the report from EFSA includes in all the pathogens the concept of subtyping and the importance to have subtyping of the different bacteria. So here you can see the CC. What is CC? It's clonal complexes. So it's, if you have a Listeria mono, then you have a lineage. You have in total 4 lineage, and then under the lineage you can classify by genetical definition or composition the clonal complexes. So you can see here that the document is already identifying which clonal complexes are more persistent in the food environment. So you can see on the right the 1-to-1, it's one of the more persistent with more than 20 times isolated. Then the clonal complex 8, 9, and 5. So this is helping us to understand, because not all Listeria monocytogenes are the same, and the clonal complexes allows us to understand what are the risks and what is more relevant once Listeria mono has been detected. And then in the different colors, you can see also the food sector, so meat, fish, or the different areas when those clonal complexes has been isolated. pay attention that this document is taking sources from literature. So that in general, we know that 1-to-1 is one of the more persistent in food environments, but the sectors can be biased because the number of papers and documents used for this literature. So knowing that the clonal complexes are more persistent and more relevant, then we can identify also by subtyping which are more hypervirulent or hypovirulent. So hypervirulent is high risk to generate an illness or to generate a die, let's say, or when you have sick. So we know that clonal complexes 1, 4, and 6 are hypervirulent, but other and 1-to-1, 9, and 31 are hypovirulent, so less virulent. So that's good for the food industry because even if Listeria mono should be considered always as a pathogen, then we know that the most isolated in food industry is an hypovirulent. So meaning that less risk to have a big impact in public health, but it still needs to be considered as a pathogen. Also, we know about persistence, as I told you before, and now it's we know that the 1-to-1, 8, and 9 are more persistent. So if we isolate Listeria and we identify that is belonging to the clonal complex 1-to-1, we can already start to take actions knowing that it's very probable that this strain is not coming from the raw materials or it's having a strong persistence in your environment. So, and then it will be more difficult to fight against this an strain from 1-to-1 than a strain from a non-persistent clonal complex. And then also it's important how are classified in terms of clinical or food-related strains. So here, this document is not in the document from EFSA in the scientific opinion, but is from Mérieux et al. Published in Nature Genetics in 2016, and you can see here that the biggest is the number of isolates are not related to persistence, but you can see here that the most frequency isolated in food is the 1-to-1 and the 9 and 5 and 8. And then in clinical, the most frequency isolated is the 1, 6, and 2. So you can see that still we have discrepancies and we don't know why this gap. We don't know why we cannot associate the most frequently isolated in clinical isolate from sick people or the more isolated from food. So it's still a question to resolve, but just to highlight how important it is to define the clonal complexes and to understand if it's more associated with a clinical or with a food strain. To finalize, also, the persistence of Listeria mono is multi-year outbreaks. So I just put it some examples of the subtyping allows to understand if the strain that is in my food or in my environment is being for years there. So here, for example, I put the publication from the FDA, the Food and Drug Administration in US, where it's described the Listeria monocytogenes diversity and how the ice cream outbreak that it was during several years and conducted to environmental facilities was isolated in the original ice cream factory, and then it was linked to the different outbreaks and the isolation for several years. Another example, for example, also subtyping of cheese production environment in Switzerland associated to outbreak. You can see that 2018 until 2020, and finally in 2020 was cheese dairy identified as the source, and it was a recall. But the strain was persistent in the outbreaks since several years ago. And another one, a big outbreak in processed meat in South Africa, that again, you can see that from the beginning of 2017 were samples detected, and then the alerts started mid-2017. And then when the facility was inspected and sampled, then drastically the actions were taken and the outbreak was practically stopped in few weeks. So, but you can see almost 2 years time persistence and having impact in the food industry. And to finalize with listeria, this was an outbreak in Spain. I'm originally from Spain. This was for south of Spain, and it was an outbreak with 4 people died and more than 200 people sick. And at the beginning, this is a report from the European surveillance document. It was defined that pure hygienic conditions in the facility explain the contamination, but also this went to the court, and it was detected that the strain that was linked to the outbreak was already detected some years before, and was communicated to the owner and the son of the owner of this facility, and then they were in jail for 4 years. So you can see that it's a big impact. They were associated to a persistent listeria strain in those facilities. The report is also including that listeria mono niche. So I'm not going to define, but if you want, go to the report. It's free available in the website, and you can see that food contact surfaces and non-food contact surfaces are isolated and the clone are complex, and also in different sites on your facility. I'm not saying you need to build your environmental plan, and it will be the second webinar on only analyzing those points, but just giving some ideas about which points are mostly associated to the listeria risks. So that's the objective of this document. So let's go for Salmonella. Again, Salmonella, you can see a big difference. It's more than 65,000 cases of illness in 2022 and 81 deaths. Still 81, but you can see that the risk considered with listeria is a risk of death is much lower when you are impacted by Salmonella. And again, 86 outbreaks related with eggs, mixed food, pig meat or other products, and also chocolate and biscuits and bakery. So you have again here what are the outbreaks associated and the total foodborne outbreaks. So in the report, you can see that, of course, we have a big number of Salmonella serovar. We have more than 2,000, but only small numbers are associated to outbreaks. I'm not talking about persistence, but outbreaks. So 75 of the outbreaks are associated to Salmonella enteritidis, Typhimurium, including the monophasic state. And here, you can see what are the clusters with more than 100 isolated. So again, Typhimurium and enteritidis are covering the big number of clusters, meaning that are associated. This graphic is not persistence, is what are the strains isolated for environment, for clinical, and for food facilities. Then you can identify the serotype, of course, following the classical serotyping method included, for example, in the ISO standard, but also you can identify by molecular, and these clusters has been identified by molecular sequencing. Again, the persistence. So one is what are associated to food and what is associated. So in terms of serotypes linked to persistence, we have a high number, and then you can see again meat is highly associated with Typhimurium. Then agona is more relevant in feed, in animal feed, but also in meat. Salmonella derby in meat, and Salmonella natum, of course, in animal feed. So again, this is helping you to define which are the serotypes more relevant that you must or you should take into consideration when looking for persistence. Why Salmonella persistence? So also we know that the genotypic and the serotype is associated to resistance to antimicrobials and disinfectants. The ability to form biofilm, it's also, Salmonella can also generate biofilm, and is very good to survive and grow in food. Listeria is not very good fighting to get to grow well in food, but well in the environment. But Salmonella is vice versa. So Salmonella is very good to grow in food when having different barriers or having high background flora, while Listeria is not able in food with high background flora in general. And the Salmonella could be persistent also because the genetical traits like mobile elements, plasmid, virulent genes, and also mechanisms to improve the cellular invasion when it's in the body. to finalize with Salmonella, again, in the report you can find which are the places in your factory when you are associated. So you can see that some are associated to the drain sampling. Almost all can be isolated or are isolated for equipment, and a combination on food contact coming from feed, and also for non-food contact. And last bacteria that I want to describe is Chronobacter. Maybe you know why Chronobacter, if you remember, Chronobacter was described in the regulation and in the previous ISO standard as Enterobacter sakazaki. And then the group was moved to Chronobacter, and it's coming from the Greek god Kronos, that for Romans was Saturn. And the name is coming because Saturn or Kronos devoured all his sons as soon as they were born. So it's a bacteria highly associated to childs with less than 6 months, to babies with less than 6 months in general, and associated to the feeding of the babies. So because that was associated to this god. So again, the report is highlighting that the Chronobacter in this case is persistent because it's high osmotolerance and high resistant to desiccation. So again, if you remember, was associated to low moisture foods. Also relative high heat resistant, and is attached in biofilms, also having biocide resistance because the desiccation characteristics, and also is resistant to UV light, oxidative stress, and desiccation by the carotenoid pigment. If you remember the previous method, we identified Chronobacter because the yellow pigment now is not anymore, because we know other Chronobacters cannot generate yellow pigment, but this yellow pigment on Petri dishes is something that is generating resistance and persistence. And here you can see it's not in the report of the EFSA, but a paper from 2007 showing persistence of different strains in infant formula. And you can see that for some strains, more than 2.5 years can be there. And also, depending on the clonus complex, so again, infant formula facility, a factory, was sampled for several months. And then they also found in Switzerland that after 13 months, they recovered clonal complex 4, and then was found persistent for up to 4 years in the product facility. And then you can have here a short summary of the clonal complexes on Chronobacter detected. With this, I'm going to the conclusions. So for me, the conclusion is the more persistent pathogens in food and feed processing environment are Listeria monocytogenes, Salmonella, and Chronobacter. Both phenotypic and also genotypic features are impacting persistence, and the typing is crucial for root cause analysis and source attribution, as you will see in the future in the other webinars. And also, environmental sampling and testing program is the most effective strategy to identify the sources and detect and react. I have another slide for the conclusion from Brice, but I'm going to skip this part if you don't mind. And then I give the floor to the other speakers.
Thank you, David. So I don't know about you, but with the jail story and the Kronos story, I'm a little bit scared about pathogens. So I will let now the floor to Brice. So I think everything is working, but I have your presentation in case, Brice.
Yeah, we try to do. So yeah. Is it okay now?
Yes. Try the full screen. Full screen.
I am in full screen.
Okay, we don't see the diaporama mode.
Okay, so I will try to.
It's not the good one, in case.
Yeah. And now? Not better?
Nothing for the moment.
Okay, let's now do another try. Or you can share the screen then.
Okay, so here we go. Do you see Brice? It's okay?
Yeah, Okay, I will try to go a little faster. When we
Okay.
prepared the
Okay, let's go. I let
okay,
you the floor.
okay. So when we prepared this series of webinars, we thought it would be probably important to give some background of this scientific opinion before presenting and commenting in more detail. Thank you, David, for taking the floor before it was we should have done organize the meeting, the event. And as you will see, and as also David said, the perimeter of the scientific opinion is purposely limited, but its conclusion have a wider significance and a larger interest for food business operator. So you can move to the next slide. So I will go quite fast about that. Just about EFSA, more people are aware of EFSA, but there is always a context when a question is asked to EFSA, and mainly about risk, food risk, and about this we have been talking for more than 30 years about repeated occurrence of the same microbiological hazard on food and feed production. And as with the example given by David, we have been facing also several outbreaks in some countries across Europe. And beyond this media crisis, this is of course poses a real public health risk that was to be dealt with by European level and but also by member state authorities. And of course, this crisis this risk represents huge economic loss for food business operators. In this context, next slide. Yeah, in this context, EFSA was asked to deliver a scientific opinion on the persistence of microbiological hazard in food and feed production and food processing environment. And to be able to deliver this opinion, as usual, EFSA has defined certain terminology to be sure that we are talking about the same thing. And this is of most important, of course, for this opinion. But it's really important that we are aligned when we talk about microbiological persistence. So we have here some very important elements of or criteria to define microbiological persistence. And the first one is the ability of a given microorganism to be established in niches or harborage sites within the food and feed processing environment for long term, despite, and this is important, despite the frequent application of cleaning and disinfection. If you find a recurring, and this of course may lead to a recurrent food contamination event as shown by David. But I come back to the cleaning and disinfection. If you find a recurring bacteria in a place that it is not clean or not clean but not disinfected, we should not talk about persistence. So the fact that it has to be clean and disinfected is very important. Just comment about two terms, niche and harborage sites, because there was a lot of discussion about that. Niche is more, I would say, more closely related to the notion of ecological niche, whereas harborage site is more related to a place just providing shelter to the bacteria. Then microbiological persistence required a prolonged existence in this specific niche or harborage site, with usually multiplication, but multiplication is not always necessarily. And the third important point is that the repeated isolation of the same strain from the same premises or equipment on different dates or period of several years is also important to define persistence. And when we also talk about the same strain, this means that the strains has to be subsequently identified as highly related subtypes using phenotypic methods or genotypic methods that are more accessible nowadays. And David showed some examples about this a few minutes ago. And also some comments about presumed non-persistent, that is defined in the EFSA comments, is that is used here to emphasize the fact that repeated contamination is required to really speak about persistence. Even sometimes it's not so easy, but this subject will be maybe clarified during the second webinar. And finally, persistence should not include continuous reproduction in the facility of the same microorganism. This also has been some debate. From a technical point of view, methods are evolving, and we will be able, and we are now able, to make the distinction between continuous reproduction and strands persisting in the facility. And we will have also some insights during the third webinar. We can move to the next slide. So this is basically what was asked by to EFSA regarding the microbiological persistence. And they are generally organized in terms of interreference, terms of reference that are translated in assessment questions. And now we can move to the next slide because David presented the first questions about which hazards, which types, how, and I will focus now on the second part. And you can, there is a small animation, Guillaume, you can click on that. So David presented that, and I will focus on the second part now, and we can move to the next slide. As I said, we have this is a general, this is a scientific evaluation based on literature, as David mentioned. But when we look about persistence and risk factor, it comes quite to basic things, and you. Even if persistence is a multifactorial process that depends on specific environmental conditions and risk factors are given here. David talked about Listeria monocytogenes, Salmonella, and Chronobacter saccharaki. And you will not surprise that the main risk factor identified by EFSA is a poor hygienic design of equipment and machines, as this leads, of course, to harborage sites that are consistently or constitutively, I would say, more difficult to clean. And if it's difficult to clean, it's difficult to disinfect. And of course, as it is difficult to clean, food debris and moisture can accumulate, and the hazards then can at least survive and more likely to multiply. Other important factors that I will detail as short as possible are inadequate zoning and hygienic barriers that enables the spread of contamination from contaminated to clean areas, inadequate cleaning and disinfection of the facilities, introduction of hazards through raw materials, which may lead to the colonization and spread of persistent clones in the processing environment, humidity, which favor persistence, and for hazards of relevance in dry processing environments. We also may have airborne contamination through dust. So we can move to the next slide. I already detailed that with the risk factor, so we can move to the other one. On the one. Okay. Regarding the measure to prevent microbiological persistence, is then quite, I will say, quite straightforward, with identified risk factors on the left, when during the assessment of EFSA, based on the literature, the biohazard panel emphasized that the establishment of hygienic measures within the food safety management system during implementation of HACCP is key to prevent and control bacteria persistence in the food and feed processing environment. As this hygienic measure avoid the entry of hazard to the processing plant or the spread across the facility. And this is illustrated on the right on this figure that comes directly from the scientific opinion, which clearly recall the importance of fundamental prerequisites, they are called PRPs of particular importance, that perfectly connect to the main risk factor identified through the Ishikawa diagram and 5 M's with material, machine, method, medium, and of course, manpower. They identify then 6 prerequisites of particular importance: infrastructure, building and equipment, because this relates to several risk factors such as hygienic design, zoning, hygienic barriers, humidity, aeration, and cleanability. The second PRP, cleaning and disinfection, is critical because it prevents bacterial persistence, and a lot probably should be detailed and highlighted on cleaning and disinfection PRP. And I would highly recommend EHEDG guidelines, which cover, of course, hygienic design, but also cleaning and disinfection and validation, surveillance and monitoring of cleaning and disinfection. The third PRP is technical maintenance and calibration that should maintain performance, but also hygienic design and cleanability. Then we have water and air control linked to identified factors such as raw material, aeration and dust, but also, of course, cleaning and disinfection. And then I would tend to group the 4 last PRP identified by the biological hazard panel: working methodology, personnel, and food safety culture. Because of course everything is interrelated, and I won't go into detail about the food safety culture, but it's really important to if it's regulatory in Europe, but it's of course regulatory. So I will say that or add a comment that okay, it's simple, common hygienic measure related to standard and essential prerequisite program. And of course, these are key to prevent and to control persistence. But simple doesn't necessarily mean that it's easy to keep up on a daily basis. And probably a lot of people attending the conference are aware how hard it's difficult to do simple things. I can. There is another side, Guillaume, about other. I focus on preventive measure, but there is also other measure for monitoring and controlling persistence. I will skip those as environmental sampling and seek and destroy approach, systematic root cause analysis, and of course confirmation of persistent strains will be discussed during the other seminars in September and October. And then I will move to there was a conclusion of this on the slides from David. But my conclusion, well, I will say that persistence is a multifactorial process that depends on the ability to persist, as shown by David, but also on specific risk factors I presented. And those main risk factors are lack of hygiene design of equipment and machines, inadequate nose zoning and inadequate hygiene barriers, inadequate cleaning and disinfection, contamination of raw materials, and humidity and dust. And simple hygienic measure related to standard but essential prerequisite program, which are key but not easy on a daily basis. Thank you, Guillaume. Sorry for the delay. I can let you over now.
Yeah, thank you, Brice. No problems, huh? It happened. Sorry. So we are a little bit, I would say, late in the timing, but if you want to ask, I will show again. If you have some question, we can answer. So we have some question in the chat for you. If we have a few minutes just to answer. We have a question regarding. You already answered, David, but we had a question about what about spore formers? It is quite complicated to remove them from units in food processing industry.
Yeah, I already replied in the chat because as we were running out of time to have the reply.
Okay.
But yes, you are totally right. Spore formers are persistent and are usually in the food environment, and also can tell you not only in the food production but also in the laboratories when the powder samples are sometimes contaminating surfaces and other areas. So I can tell you that's very common. I think the report did not include spore formers as a high pathogen risk because they did not find a lot of outbreaks associated to spore formers, and also because the ability to is not routinely identified for public health questions. But then if we move to spoilers that are out of the scope of the report, this is very relevant in terms of fungi, spores, and also other bacteria like bacillus or some bacillus. In some specific food commodities, yes, spores are being there and needs to be investigated more, I would say.
Okay, thank you. Yeah, go, Brice. Sorry.
Yes, this is also what we said, that okay, the scientific opinion and a very precise perimeter, but it's also what we David and I said. The conclusions of this opinion is of wider significance and of larger interest, because many things described by the panel for this three specific pathogen are quite common to other pathogen or spoilers. And about risk factors and control measure, it will be definitely the same.
Thanks a lot, David and Brice for this webinar. Very interesting. Not so easy because a lot of information. So thanks a lot to have summarize this. I would say this scientific opinion. We will have the next session beginning of September. So do not forget to register. We will deep dive in the two parts, as you understood. Today, one part with Brice and one part with David. So we'll deep dive in those parts with monitoring hazards first in September, importance of a good environmental monitoring program to seek and destroy. We will have the pleasure to welcome Lina Otero from bioMérieux and John Ola, Director of Scientific Committee, based in UK, and we will have the third one, 3rd of October, to deep dive in the how we can, I would say, thanks to new tools, better manage the persistence of some strains in food facilities, thanks to root cause analysis, a new era, thanks to genomics, and we will welcome Magali Lediodic, expert in food safety and dry cleaning at Kersia, and myself to deep dive in the tools we are developing. So thanks a lot to all of you. If you have any question after the session, feel free to send them to us, and we will be happy to answer them. So thanks again, Brice and David. I wish you a good afternoon and good travel, David.
Thank you.
Bye-bye.
Thank you very much.
Bye-bye.